Hello, hello. We are back to talk about pyruvate oxidation. And so the first I can statement is I can describe the process of pyruvate oxidation. And the name is going to tell you exactly what happens. We have pyruvate, which we made in glycolysis. And if you don't remember that, you might want to go back and watch the glycolysis video. And to oxidize something means to remove electrons. So that is what we're going to do. We're going to remove electrons from pyruvate. So this one's good and easy, tells us exactly what it does. All right, the other two I can statements are I can list the reactants of pyruvate oxidation and I can list the products. So what we're going to do is we are going to draw this out so that those of you that are visual can see what's going on. Okay, it's acetyl-CoA and that's a 2-carbon. All right, so we start out with let me do it this way. We start out with a 3-carbon, okay? We break one off, that leaves us with a 2-carbon, that's our acetyl-CoA, and when we broke the bond between these 2 carbons, we released energy in the form of electrons, okay? So that's where that oxidation is happening. We're removing electrons from pyruvate. They're going to be given to NAD+, to reduce it to NADH, so this guy's being reduced. This one's being oxidized, which we already knew that because of the name. And then we do have a CoA coming in, a coenzyme A. Okay, that's where that CoA comes from. And we are going to lose, because we lost a carbon, we're going to lose a CO2. This oxygen is coming off of this pyruvate as well, so that whole molecule is coming from the pyruvate. And so that is that. No ATP made, so don't have to worry about any phosphorylation. So let's look at our reactants. And our products. Okay. Oh, one other thing I forgot to mention. If you'll remember in glycolysis, we had one glucose, and it's split into 2. I know you can't see that because I'm left-handed and it's hiding what I'm writing, but there you go. I don't need pyruvates there. It broke into 2 pyruvates. So I only showed 1. So what you need to remember is that this is happening times 2. You could also put 2's in front of all of these if you'd rather. It doesn't matter. But in my reactants and products, I'm going to put the total that we produce per glucose. Okay, so I'm going to put the total that are produced when we do this 2 times because we started with 2 pyruvates. So the reactants were 2 pyruvates, 2 NAD+, okay, so that's coming in right there, and 2 coenzyme A, okay. Our products are 2 acetyl-CoA, 2 NADH, okay, and 2 CO2, okay. So 3 things coming in, 3 things coming out. Pyruvate becomes acetyl-CoA, coenzyme A also becomes acetyl-CoA, the NAD+ becomes NADH, and this carbon comes off of the pyruvate. Okay, and so that is it. These are the reactants, these are the products, this is the overall process. And again, the whole goal of this is to break down this glucose, which is now broken into these pyruvates, but it's still coming from glucose, is to break down that glucose and release the energy little bit by little bit by little bit. And so that's what we're doing. We're releasing tiny bits of energy by breaking off that 1 carbon, and that energy is going into the NAD+ to make NADH as those electrons move from the pyruvate, because it's oxidized, to the NAD+, which is reduced. So that is pyruvate oxidation. If you still have questions, need help, or just want to go over it again, let me know. And like I said, it's always good to draw these out a couple of times, especially if you're a visual learner. That really, really helps to kind of get it into your brain.